Welcome. In this video, I'm going to be going over the class discussion for Unit 1, Activity 3. So the author of these notes loves apples. They love them so much that they buy and eat at least one apple per day. And in the table below is a recording of the number of apples purchased each day last week and the amount of time paid each time. Or amount of money, paid each time. Not the amount of time. The amount of money paid each time for the apples. So if you can see, one day they bought 2, then 3, 1, 2, 1, 3, 4. If I buy 2 apples tomorrow, how much do you think I will pay? So let's look at our table. We can find 2 apples here and here. One of the days, the author paid $1.50. The other day, the author paid $1.75. How much do you think they will pay tomorrow? And this is not really that clear. So it's unclear how much they'll pay tomorrow because they've paid different costs on different days. So unable to determine the cost since the author here has paid $1.50 on one day and $1.75 on a different day for the 2 apples. So we really can't determine how much they'll pay. Part B, let's change just one of the numbers on the table above so that every number of apples purchased has just one cost for the number of apples purchased. So let's quickly check. We know that 2 apples has 2 different costs. What about 3? Here's 3 apples for $2, and here's 3 apples again for $2. What about 1 apple? Here's 1 apple for $1, and here's another apple for $1, so the cost is the same. What about 4 apples? Well, for 4 apples, they paid $2.50 one time, so there's only one cost for 4 apples. So our only problem lies within the 2 apple category. So I personally like a bargain, so if I had to make my prices, I would change this to $1.50. So now we change the cost of 2 apples so that 2 apples always cost $1.50. We didn't actually have to change both of the costs, just one of them suffices. And I could have changed this one to $1.75 and left this one the same, and that would still work out to always knowing that 2 apples cost $1.75. So either way, it doesn't matter. Now, after your correction in Part B, the table now shows a function that is each input has exactly one output. Does this table show a linear relationship? Let's remember to justify our response in our calculations. So now that we know it's a function, we have to determine if this is linear. So I'm going to rewrite this table in a simplified form, and I'm going to call the inputs x and the outputs y. And I'm going to write 1, 2, 3, 4, since this is going to make my table a lot easier to read. And for 1 apple is $1. For 2 apples, it was $1.50. For 3 apples, it was $2. And for 4 apples, it was $2.50. So now we can see the difference between these values, between these y's. So here, an increase of 1 in the x's gives us an increase of 50 cents, or half a dollar. On the next one, we have that same increase. And on the third one, we have the same increase. So for every apple purchase, the cost increases by 50 cents. So this is a linear relationship. I want to add, if you had changed the cost of 2 apples to $1.75, then this would no longer be true, and we could no longer say this is a linear relationship. So for Part B, you could change it to either answer, $1.50 or $1.75, but for Part C, your answer will vary depending on your choice for Part B. Take a moment and read the rest of this page independently.